Okay, guys, welcome back. This is day 9. We are getting to the end of week 4 of NTI. At this time, I'm hoping that this is one of the last videos I have to make, and then I'll see you guys in May. But who knows? Everything could change by the time you guys watch this video. But I'm staying optimistic for now. So we are on still chapter 6. We're on example 4. We are modeling with exponential functions. Last time we took like an exponential growth problem and we created the equation ourselves, and then we used it to solve. Okay, so before we dive into this one, let's review what we learned from the last video. We know that exponential growth is a times b to the x. We know that a is our initial value. We know that b is our growth factor, and again we'll break that down in a second. And then we know that x is our time. Okay, so again, breaking down the b, we know that b can either be 1 plus the rate or it can be 1 minus the rate. We know that plus is growth and minus is decay. So this right here is actually where we get the if b is greater than 1, that it's growth. Because we can see if we have 1 plus a number, 1 plus anything, that number is going to be bigger than 1. So when b is a number that's bigger than 1, we know that we added something, so that must be growth. And then we know that when it's 1 minus a number, anytime you've got a number minus something, it's going to be less than 1. So if we look at a number and it's less than 1, it's a fraction of some sort, then we know, or a decimal, then we know that it had to have been 1 minus something, which is why it's decay. So we're going to use this information to take a look at our problem over here. Okay, so it says a car was purchased for $24,000. The function is modeled y equals 24 times 0.8 to the x, can be used to model the value of the car in thousands of dollars. Okay, so notice they had $24,000. They just chopped the zeros off and made it 24, and they're just going to use the unit of thousands, kind of like we did in the last problem. So first question, does the function represent exponential growth or decay? The answer is in the b value. Okay, we're looking for this. So we've got the function y equals 24 times 0.8 to the x. So if we line that up with our equation, we know that a is 24, b is 0.8, and x is x. So if b is 0.8, is this function growth or decay? We have to ask ourselves, is 0.8 bigger than 1? Or is 0.8 less than 1? Remember, a decimal represents a fraction. It means it is less than a whole. So 0.8 is less than 1, which means that this is decay. Okay? When you buy a car, and this is true to real life too, when you buy a car, typically the value decreases. Okay, the car will never be worth as much as when you drive it off the lot. Think about like if you've ever tried to resell a cell phone or a tablet or something. You may have bought it for $500, but when you go to sell it to your buddy after it's been used, now it's only worth $300. That's what's happening with the car. The value is decaying, it's decreasing. So part B says, what is the rate of decay for this function and what does it mean? So you might think like, oh, well, B is the rate of decay, but it's not. B is the growth factor, okay? That's whether it's getting bigger or smaller. The rate is R, okay? So we know that B in this problem is 0.8, and we also know that B is what, okay? Is B 1 plus R in this situation, or is B 1 minus R? If it was a decay problem, which we know from up here, then we should know that this B was a 1 minus R. We want to know what that rate is. What number did we subtract from 1 to get the B value of 0.8? So if b is 0.8 and b is also 1 minus r, then that means that, I'm just going to change up the color a little bit, that means that 0.8 is also 1 minus r. If both of those things are b equals b, so I can say 0.8 is 1 minus r. So what I want to know is, what is r? I'm just going to do some algebra 1. I want to get rid of this 1, so I'm going to subtract 1 on both sides. If you're not good at adding and subtracting with decimals, make sure you use a calculator, but 0.8 minus 1 is negative 0.2. That leaves me with a negative r. Remember, if nothing cancels out that negative sign, it stays there. And so now I want to get r completely by itself. So I'm going to divide both sides by negative 1, which makes all these negatives cancel out. And r equals 0.2. Okay? So that means that our rate of decay is 0.2 or 20%. And that means that it loses 20% of its value every year. Okay, so because b was less than 1, we knew it was decay, and then taking that 0.8 and setting it equal to 1 minus r, we knew it was minus because it was decay, helps us find 0.2, okay? So our rate of decay was 0.2 or 20%. Let me know if you guys have any questions, comments, or concerns. Email me, text me. I say this at the end of every video. You guys know the deal. I'm just trying to make sure I'm communicating with you guys as much as possible. I miss you guys so much. I miss school so much. I miss being in our classroom together and having fun and doing these notes with you guys in person, and, you know, all the fun, mindful moments and goofy things that we do that aren't just plain learning. I'm really optimistic that I'll see you guys in class again this year. So yeah, just remember that I love you so much and you guys are the best. And